Hey everyone, and welcome to today's Explainer. Today, we're exploring a seriously innovative e-twinning project called Our World in Colors. It's a dynamic, cross-cultural curriculum designed specifically for 6 to 12-year-olds. We're going to unpack exactly how educators are taking the universal language of color and using it as a foundational tool to teach everything from basic biology to advanced computer programming. Let's kick things off with a massive number, 20. We are talking about 20 partner schools uniting across international borders to completely reshape how primary students learn. This isn't just one isolated classroom trying something new. It's a huge, coordinated initiative building a multidisciplinary curriculum around something as simple and brilliant as color. Here's our roadmap for today's Explainer. We'll start with the global color canvas, move into blending art and academics, check out coding with colors, and wrap up with a colorful cultural connection.
All right, Section 1, the global color canvas, setting the educational scaffold.
So the foundational architecture of this project relies on 5 core pillars, or expected outcomes. We're looking at academic, artistic, cultural, digital, and shared space. And honestly, these act almost like a Trojan horse. By framing the entire curriculum around the fun, universal concept of colors, educators can seamlessly slip in some incredibly rigorous skills, from scientific data collection to intercultural respect, without overwhelming these young students.
The learning journey actually starts right on a micro level, right inside the students' homes and classrooms, with good old-fashioned color hunting. Kids literally go hunting for everyday red objects. Think toy tractors, ribbons, keychains. It sounds super simple, right? But it physically engages them, grounding the totally abstract concept of learning directly into their immediate physical world.
And that physical engagement goes even further. Students then interact with color from a scientific perspective by extracting natural pigments. They take raw, natural ingredients, literally mashing up orange carrots, dark beetroots, and sweet bananas to organically create vibrant homemade paints from scratch. It's chemistry, biology, and art all mixed into one wonderfully messy, hands-on lesson. For educators, it absolutely proves that the best science labs often start with everyday ingredients.
Moving right along to Section 2, blending art and academics, the spectrum of learning modalities.
What's really fascinating here is how the project bridges traditional crafting with modern tech. It's a brilliant contrast. One moment, students are painstakingly painting these beautiful geometric color wheels by hand, and the next, they're in Italy collaboratively solving interactive digital jigsaw puzzles on a smartboard. It is the exact same subject matter, just experienced through entirely different complementary mediums.
And this multimodal approach builds so naturally into mathematics. This isn't just about making pretty pictures. It takes kids through a highly logical multi-step algorithmic process. First, you identify the color key, then you solve the math equation, and finally, you apply the color to reveal a hidden image. It's a genius way to teach procedural thinking early on.
It's amazing to see how absorbed these Romanian students are in their math and colors worksheets. By using vibrant colors as the immediate visual reward for accurately solving math equations, the project totally removes the anxiety we often associate with math. The color becomes the incentive, turning arithmetic into a super engaging puzzle.
This cross-pollination spreads wonderfully into science and biology, too. For World Animals Day, students in Croatia and Romania use these intricate dot-in-line coloring techniques. So they aren't just casually coloring, they're actively observing the anatomy of wolves, deer, seahorses, and elephants, perfectly combining biological awareness with detailed artistic execution.
All right, let's jump into Section 3, coding with colors, digital and technological outcomes.
Now this is where things get really wild. The project smartly introduces platforms like Microsoft MakeCode to teach actual computer science fundamentals to kids as young as 6. They transition students from basic color recognition straight into advanced logic labs, variables, and algorithmic thinking. And they rely entirely on the one thing the kids have already mastered: color.
In action, it's incredible. You have students in Turkey physically interacting with code. Because platforms like MakeCode use color-coded blocks for different functions, like blue for basic commands or pink for input, the kids can easily navigate the interface, tapping and dragging on a giant smartboard to build complex digital logic sequences.
Just look at the level of computer science they're achieving. By snapping these colorful blocks together, young minds are effortlessly grasping highly complex concepts, Boolean elements, variables, conditionals,
loops, and logic gates. I mean, these are concepts a lot of adults struggle with. But here, the visual language of color makes abstract logic totally tangible.
And they reinforce all this digital learning with interactive web tools, creating a completely gamified environment. Take these students in Romania participating in digital quizzes. They're using laptops and smartboards to compete, play, and lock in their knowledge. It proves a vital takeaway for us today. When you structure information visually, engagement absolutely skyrockets.
Which brings us to our final section, Part 4. A colorful cultural connection, the shared space.
The project's logo really captures the ultimate goal here. It shows a circle of distinctly colored, diverse individuals holding hands around one unified globe. It visually states exactly what this curriculum proves. Despite completely different languages or geographical locations, these students all share one collaborative educational space.
But, amidst all the heavy math and coding, the project never loses that artistic humanity. Listen to this excerpt from a collaborative poem the students wrote. Sweet-smelling purple hyacinth. Looks so good next to it, purple pansy, pink rose. It's such a delicate, sensory exploration of color that grounds all their digital work right back into the natural world.
And seeing the students gathered around their smartboards, actively reading and sharing these exact poetic words written by their international peers, it just brings the emotional impact of the whole curriculum to life. It is the perfect synthesis of digital technology and real human connection.
And the scale of this is just massive. This incredible learning isn't isolated. It's a huge unified network of classrooms. With 10 partners in Turkey, 5 in Romania, 2 in Croatia, 1 in Italy, plus partners in Bosnia and Herzegovina and Greece, it forms this vast cross-border web of young minds, all operating on the exact same colorful wavelength.
Which leaves us with a pretty big question to end today's explainer. Think about what these 6 to 12-year-olds are already achieving. If the simple, structured concept of color can successfully connect classrooms, teach advanced coding, and bridge cultural borders today, what boundaries will these globally connected students cross tomorrow? Thanks for exploring the source material with me today. Keep learning, keep asking questions, and I'll see you in the next explainer.